find first eigenvector. So you will get, you can see, multiply second row with 1 plus I. So first row is as it is, -1 1 plus I. Second row become 2 and -2 into 1 plus I, correct? 2 and -2 into 1 plus I. So first and second row are actually linearly dependent. You can see whenever you multiply first row with 2 and add into the second row becomes 0 row. You just see that matrix. Whenever you multiply first row with 2 and add into the second row becomes 0 row. Both the element become 0. So we will get only one equation, that is -x1 plus 1 plus I into x2, that is equal to 0. So now multiply with -2, so you will get 2x1 -2 into 1 plus I into x2 is equal to 0. So both the equation are same actually. Now taking x2 is equal to 1, because of second column does not have leading entry, so that's why we take x2 is equal to 1. We get x1 is equal to 1 plus I. So the eigenvector corresponding to lambda is equal to 8 is 1 plus I, 1. So now norm x2 is equal to under root 1 plus I square plus 1 square, that is equal to under root 2 plus 1, that is equal to under root 3. So divided by x2 with its norm, that is 1 plus I by root 3 comma 1 upon root 3. So now put this both eigenvector as a column in such matrix in the matrix P. So you will get P, see the first column, right? Taking P1 and P2 as columns, we construct the matrix P as follows. The first column is P1, which is our eigenvector corresponding to lambda is equal to 2, that is -1 plus I divided by root 6 upon the second element in the first column is 2 by root 6, and second column first element is 1 plus I divided by root 3 and then 1 upon root 3. So first column is exactly the eigenvector corresponding to lambda is equal to 2, and the second column is exactly the eigenvector corresponding to lambda is equal to 8. So now this matrix P is a unitary matrix. If you want to check, just you have to check P star into P, that is equal to P into P star, that is equal to identity matrix. Okay, and I already explained that what is the meaning of P star, that is I recall you that P star is equal to transpose of the conjugate matrix, right? So here the complete the solution, and definitely P inverse AP, that you should know that whenever we find P inverse AP, that is in main diagonal in any matrix, the main diagonal we have to put eigen value, right? Other elements are 0. So here we have 2 cross 2 matrix. So what are our eigen values? 2 and 8, right? So in main diagonal we have to put eigen values, that is 2 and 8. The other elements are 0, right? So here the complete the solution of this question. And next question, question 5c. First, prove that every square matrix A can be expressed as a sum of a symmetric and skew symmetric matrix, right? Symmetric and skew symmetric matrix. Now first of all you have to try to understand that what is the meaning of symmetric and skew symmetric. A matrix A is symmetric if A transpose is equal to A, and a matrix A is skew symmetric if A transpose is equal to -A. So just the definition that you should know, that what is the meaning of symmetric and skew symmetric matrix. Now here is the solution. Let A be a square matrix. We can write A is equal to 1 by 2 into A plus A transpose plus 1 by 2 into A minus A transpose, that is equal to P plus Q. Okay, just take P where P is equal to A plus A transpose divided by 2 and Q is equal to A minus A transpose divided by 2, right? So now definitely we written A as a sum of the P and Q, right? As a sum of the P and Q. Now I want to try to explain you that P is a symmetric matrix and Q is a skew symmetric matrix, right? So we prove now that P, which is A plus A transpose divided by 2, is a symmetric matrix, and Q, which is A minus A transpose divided by 2 is Q symmetric matrix. Okay, so just try to prove. We have P transpose. So now for, if you want to prove that P is a symmetric matrix, what you have to prove? P transpose is equal to P, right? P transpose is equal to P. So starting with LHS, which is P transpose, that is equal to 1 by 2 into A plus A transpose of whole transpose, right? So instead of P, just I put the value of the P, that is A plus A transpose divided by 2, the whole transpose, that is equal to 1 by 2 is a constant, so that can be outside from the bracket. 1 by 2 A plus A transpose of transpose, that is equal to 1 by 2 into A transpose plus A, because of we know that A plus B in bracket A plus B whole transpose, that can be written as A transpose plus B transpose. Okay, so we use that property, that A plus A transpose that can be written as A transpose plus A transpose transpose, that is exactly A. Okay, A transpose of transpose, that is equal to A. So we get 1 by 2 into A transpose plus A, that is equal to P. Okay, that is equal to P. A transpose plus A can be written as A plus A transpose, right? So that is equal to P. So we will get we get P transpose is equal to P. So that's why P is a symmetric matrix. And now try to prove Q is a skew symmetric matrix. Just starting with Q transpose, that is equal to 1 by 2 A minus A transpose of transpose, that is equal to 1 by 2 will be outside from the bracket. So because 1 by 2 is a constant, 1 by 2 into A minus A transpose of transpose, that is equal to 1 by 2. Again we use that property that A plus B transpose, that is equal to A transpose plus B transpose. So that's why 1 by 2 into A transpose minus A. Okay, so that is equal to, now A transpose minus A can be written as a minus of A minus A transpose. So that is equal to minus 1 by 2 of A minus A transpose, and that is exactly the minus Q. So we prove that Q transpose is equal to minus Q. So that's why Q is a skew symmetric matrix. And we already defined A, we already express A as a sum of P and Q. Okay, and now we prove that P is a symmetric matrix and Q is a skew symmetric matrix. So that's why we can say that any square matrix A can be written as sum of the symmetric and skew symmetric matrix. Okay, so here is the proof, and this question asked in 2 marks in this question paper. So next question, question 5C, second part. This question asked in 2 marks in this question paper. Is A, where A is a 3 cross 3 matrix, starting with the first row is 0 minus 3 plus 2i minus 2 plus I. Second row is 3 plus 2i 3i, 3 plus 5i 2 plus I minus 3 plus 5i 2i, a skew Hermitian matrix. Okay, now skew Hermitian. What is the meaning of skew Hermitian matrix? Hermitian and skew Hermitian. First of all, just try to understand what is the meaning of Hermitian matrix. Now Hermitian matrix is, if A is a Hermitian matrix, that means A star is equal to A. I already explained that what is the meaning of A star. A star is transpose of the conjugate of the given matrix. So first of all you have to find the conjugate of the given matrix and then transpose, or you can transpose the given matrix and then conjugate, both are same. Okay, there is no difference between whenever you have any matrix, first of all you transpose and then try to find conjugate of that matrix, or first of all you find conjugate of that matrix and then transpose. So both matrix are same, right? So there is no difference, but just try to understand what is the meaning of Hermitian matrix. I repeat that A star is equal to A, that means transpose of the conjugate matrix, that is equal to A, that means the same matrix, right? So and the skew Hermitian matrix is A star is equal to minus A, right? A star is equal to minus A. So here we try to prove that the given matrix is a skew Hermitian or not. Just check that, right? Just we have to check because there is a question mark. So maybe it should be maybe it is skew Hermitian or not, right? So let's start the solution. The conjugate matrix of matrix A is given by instead of A plus IB, we have to put A minus IB, right? So just we have to change the sign of the imaginary part in any complex number in the matrix, in element of the matrix, right? So 0 is same, minus 3 plus 2i, that will become minus 3 minus 2i. I tell you the first row, okay, first row. So 0 is as it is, minus 3 minus 2i, instead of minus 2 plus i, that will become minus 2 minus I, then 3 plus 2i, that will become 3 minus 2i, then 3i become minus 3i, 3 plus 5i become 3 minus 5i, 2 plus I become 2 minus I, minus 3 plus 5i become minus 3 minus 5i, and then minus 2i, okay. So this is the conjugate of the given matrix. Now we have to transpose, okay. So just transpose of that matrix, you will get this matrix A transpose, transpose of A bar, right? Transpose of A bar, that is equal to 0. You will get just transpose of the given matrix, the first row become first column. So here is the first row is 0 minus 3 minus 2i minus 2 minus I, that will become the first column, 0 minus 3 minus 2i minus 2 minus I. Second row become, just try to see on the screen and try to understand. Second row becomes second column, 3 minus 2i minus 3i, 3 minus 5i, 3 minus 2i minus 3i, 3 minus 5i. And the third row become third column, that is 2 minus I minus 3 minus 5i and minus 2i, 2 minus I minus 3 minus 5i minus 2i, okay. So minus will be outside from each element from the matrix. So minus into matrix, in matrix 0, the first row is 0 minus 3 plus 2i minus 2 plus I, 3 plus 2i 3i, 3 plus 5i 2 plus I, 3 minus 3 plus 5i 2i. So that's why you will get A star is equal to minus A. You see that the given matrix, the right part, the right side of the first, in the first step, whatever the matrix is exactly the A, you can see, right? 0 minus 3 plus 2i minus 2 plus I, 0 minus 3 plus 2i minus 2 plus I. So same matrix, right? You will get. So that's why A star is equal to minus A. That's why you can say that A is a skew Hermitian matrix, right? So question number 5 is complete. Now this question is or question number 5, right? So start with question 5a. Find the eigenvalues and basis for the eigenspaces of the given matrix A. Here is a 4 cross 4 matrix, so it's quite little bit long example because you have 4 cross 4 matrix, right? Generally in question paper, normally 3 cross 3 matrix you have in question paper, but here is a 4 cross 4 matrix. So right, find the eigenvalues and basis for the eigenspaces of the given matrix A, where A is equal to, the first column is 0 0 2 0, first row is 0 0 2 0, second row is 1 0 1 0, third row is 0 1 minus 2 0, and the fourth row is 0 0 0 1. Now first of all you have to find characteristic equation, because if you want to find eigenvalue, you have to find characteristic equation, that is determinant of A minus lambda I is equal to 0. So just in main diagonal you have to just add minus lambda, other elements become same, right? So you can see in main diagonal elements 0 0 minus 2 1, instead of 0 0 minus 2 1, now in determinant you have to 0 minus lambda, that is minus lambda, then next minus lambda, then minus 2 minus lambda, and then 1 minus lambda, other all elements are same, right? Just try to find the characteristic equation. You have to solve this determinant. So here is the solution of this determinant. Just simplify this determinant, that 1 minus lambda will be common, okay, 1 minus lambda will be common from the fourth column, right? 1 minus lambda will be common. You can see in fourth column and fourth row all the elements are 0 except 1 minus lambda. In fourth row 1 minus lambda, only the 1 minus lambda is a non-zero element, other are 0, then 0, right? In fourth column also you have only 1 minus lambda, other all elements are 0. So that's why you can take 1 minus lambda outside from the determinant, and now next you will get only the 3 cross 3 determinant, that is just remove the fourth column and fourth row, just remove the fourth column and fourth row, you will get this determinant, that minus lambda 0 2 1 minus lambda 1 and 0 1 minus 2 minus lambda 0 2, see in the screen, 1 minus lambda 1 0 1 minus 2 minus lambda, that is equal to 0. And now you can easily solve this 3 cross 3 determinant, right? 1 minus lambda, then minus lambda into, just try to see and try to understand, right, properly. Minus lambda into 2 plus lambda minus 1 plus 2 into 1 minus 0, that is equal to 0. Whenever we simplify this equation, you will get this factor, 3 factors, that is 1 minus lambda, lambda plus 2, and then 1 minus lambda square, that is equal to 0. So just 1 minus lambda square can be expressed as 1 minus lambda into 1 plus lambda. So 1 minus lambda occur in 2 times, so that's why 1 minus lambda square into 1 plus lambda into lambda plus 2, that is equal to 0. So you will get 4 eigen values. Lambda is equal to 1, 1, minus 1 and minus 2 are the eigen values of the matrix A. 1 occur in 2 times, right? 1 occur in 2 times. So just now we have to find eigen vector, right? These 4 are eigen values. Now we have to find eigen vector. So here is the how to find eigen vector, that you should know that first of all, an eigen vector x, that is x1 x2 x3 x4 corresponding to an eigen value lambda is given by the matrix equation A minus lambda I into x, that is equal to 0. So minus lambda 0 2 0 1 minus lambda 1 0 0 1 minus 2 minus lambda 0 0 0 0 1 minus lambda into x1 x2 x3 x4 is a column, into that is equal to 0 0 0 0. So when lambda is equal to 1, equation 1 become, right, just put in first equation here. The first step is our first equation, just put lambda is equal to 1 in equation 1, you will get minus 1